Hi, my name is Angelina Crittenden. I'm a TA for the USC Young Scientists Program. I typically teach 4th grade at the Alexander Science Center School. Today, we're going to learn about waves. How does light travel? Have you ever wondered what the wave part of microwave meant? Energy travels in waves, whether that's energy from a radio, a microwave, visible light, or radioactive elements. It belongs on something called the electromagnetic spectrum, which measures different types of energies. Light, sound, and other forms of energy found on this spectrum travel through the air as waves. Unfortunately, this isn't something that we can see with the human eye, as it's much too small. And we can't use a microscope either, because it's much too fast. Still, all the light we are able to see travels as waves through the air. Let's talk about the characteristics of a wave. A wave has different parts. Let's look at the wavelength first. Wavelength is the difference between two peaks or two valleys of a wave, also known as the crests and the troughs. Amplitude is the distance from the wave's resting point, which is represented by this dotted line in the center, and the crests or the troughs. Because waves all move at the same speed but have different wavelengths, differing wavelengths means different frequencies, which is how many complete wave cycles occur in 1 second. The wave cycle is from this point A to point B. We can tell how much energy a wave has if we know its wavelength and its frequency. High energy waves have high frequency and low wavelength. Now we're going to make our own waves. What you'll need for this experiment is 12 to 14 plastic straws, some clear tape, and safe scissors. Now, we know that plastic straws aren't the best for the environment, so you can also use something like tongue depressors or popsicle sticks. Let's get to it. First, I have a long piece of tape. Lay it on the table with the sticky side up. I've already cut my tape with my scissors. Then, I place each straw on the tape about 1/2 inch to 1 inch apart. An easy way to do this is to put them about 2 fingers apart. When you've placed all your straws, take another piece and lay it sticky side down over the straws. Try to line it up with the other piece of tape. Press down to stick the 2 tapes together. Now, you're ready to use your wave. You can twist or flick the ends to generate waves. Try to twist so that you make the wavelength larger or smaller. When we twist the wave more, the wavelength decreases, and when we release it, there's more energy than when we twist it less. Lower wavelength and higher frequency lead to greater energy waves. Our scientist highlight for the week is Sameera Moussa. Born in Egypt in 1917, Sameera Moussa is one of the most significant contributors to the field of atomic science. She was the first Cairo University student to earn a doctoral degree in atomic radiation, and one of the first major advocates for nuclear hazard protection. Radioactive energy emits waves with very, very small wavelengths. Sameera Moussa dedicated her research to finding ways to make nuclear technology as cheap as possible for cancer treatment. Her discoveries paved the way for nuclear research to be more accessible and cost-effective.